Hey everybody, how's it going? Mr. Knitzel here, better known as Mr. C. I teach math for Restart Academy, so I'm here to help you with a couple, or a few I should say, of the math portfolio questions. And the questions that we will be going over in my video series are questions 3, questions 4, question 5, and question 12. So I'm going to break these videos down into 4 separate videos, but they should be watched in succession. And what I mean by that is you should watch the video for question 3 before you watch the video for question 4, before you watch the video for question 5, and so on. So we'll start out by reading the objective. So the objective reads, students will be able to practice systems of equations, notice how that's bold, and complete numbers 3 to 5, as well as solving equations and practicing number 12. So when we start this lesson, and I'm going to call it a lesson because that's what it is, the first thing that we should be looking at after reading the objective is the do now. It's not shown here, but this is the do now. Write it in for you. So in this do now, we have a sentence with some blanks, and we have to fill in the blanks with words that make this sentence true in relation to systems of equations, which I will go over in a minute. So the first thing I want you to do is complete this fill in the blank section with me. So it reads, in order to, and the word I want you to put there is eliminate. And I'm going to put it there in bold. It's like my way of annotating this. So in order to eliminate, which means getting rid of something, you need the same, I want you to put this word in here. You need the same number. You need to have the same variable. Now, what's a variable? For those who don't remember, a variable is simply a letter that we use in place of a number that we don't know. So if you look at this example, it says x minus 2 equals 6. The x would be the variable because it is a letter that we use to represent a number. We don't know what the value of that number is yet, but that's why we use a variable in place of the number. So you need to have the same number, the same variable, and different signs. What do I mean by different signs? Well, something could either be negative or something could be positive. So they need to have the same number, same variable, and different signs when you want to eliminate. Now, you might be asking, what are we eliminating? I will show you. First, we need to work on a few examples. But before that, I'd just like to go over what a system of equations actually is. This word, or this set of words, systems of equations. When you read this, you just break it down, and I'm going to break it down for you. So what is a system of equations? Well, the word systems in this case means a set of or multiple of. So to be in a system means there's multiple like things inside of it. And for this problem or set of examples, it's multiple equations. So a system of equations is just simply a set of equations. And remember, an equation looks like this, where I highlighted. Again, x minus 2 equals 6. An equation always has an equal sign. If there is no equal sign, you cannot call it an equation. So let's use this definition of systems of equations to help us solve these portfolio practice questions. And I will explain these questions as I run through it, but I'm just giving you a quick scrolling guide of what you should expect to see. Um, I also have the portfolio here for you to also see. So depending on your teacher, when you solve these questions in the portfolio, it will either be on something like this, editable PDF. Maybe they'll give you a PowerPoint. Some teachers I know use Google Classroom like me, and they will be able to give you the portfolio straight on Google Classroom. Regardless of what platform your teacher uses, you could use these steps to help you solve the questions because the questions stay the same regardless of what platform or application you answer them on. So if the formatting seems a little different, just understand that the steps will be the same to solve these questions. Now, let's look at this problem set right in front of us. And this is practice question number 3. So practice for question number 3. All right. It reads, for each of the following, and when I say following, I mean following equations, decide whether there is one solution, no solution, or infinite solutions. All right. There's a lot there, so let's break that down, make it simpler. So each of the following equations, you see there are 3 total equations. And for each of these, we need to decide whether there's one solution, no solution, or infinite solutions. If you're questioning me right now and saying, what do you mean by one solution, no solution, or infinite solutions? That's good. It means you're engaged. So to have one solution is pretty simple. A solution is an answer. It's something you could use to solve something. So to solve this system of equations, or this equation, I should say, you need to solve for x. X is the variable. X is the number we don't know. So I'm asking you with this question, is there one number or one solution we could replace x with that would make this equation true? Is there no number when we put no solution? No solution means there is no number that we could put in place of x to make this equation true. So we can't think of a number that could minus 2 and equal 6. That's what no solution means. And infinite solutions, like Mr. Buzz Lightyear, means never ending. To infinity or infinite means it never ends. Or there are never ending solutions for this, meaning any number in the whole number line, which never ends, could be plugged in for x. So I know it's been about 8 minutes of explanation, but that's kind of how long a mini lesson goes. So that's a system of equations, and I'm going to show you now how to figure out how many solutions there are in each of these equations. So first, you should know that there are 3 potential ways to solve these, and one of them is through graphing, which we're going to do later. Another one of them is through substitution, which you'll see me apply in a second. And the other one is coming back to this word here, elimination, which we will use later, so don't worry. But first, let's solve these algebraically or through using the inverse operation. And I'm sure at some point this year you've had work using the inverse operation when working with equations. But if you haven't or you forgot, I'm just going to go over what that means again. To have the inverse operation means the opposite operation. So the 4 operations, I should say, that we know are addition, subtraction, multiplication, and of course, dividing, right? So to use the inverse of one of these 4 operations simply means the opposite. So let's look at this first equation that reads x minus 2 equals 6. Your job is to get the x by itself, alone, without any other number on the same side of the equal sign. So here's the equal sign. This is on the left of the equal sign, and this is on the right of the equal sign. So you need to have, again, x by itself. And the way you do that is by using the inverse operation to eliminate or remove these other values on the same side of x. And in this case, it would be negative 2. So what I do is I do it step by step, going down like a tree like this. So if x minus 2 equals 6, and I have to get x alone, I know what I need to get rid of is negative 2. Now, I just explained that the way to get rid of or eliminate this number right here is to have the same number, the same variable, and just different signs. And that applies to that whole inverse operation mumbo jumbo I was just telling you about. So let's see what we do here. We need to have the same number. That's 2. Does this 2 up here, this negative 2, does that have a variable? No, I don't see one. And this x is not the variable that goes here. So remember, this x is by itself on the side still. So in order to get rid of this negative 2, we need the same number. I got it. Same variable. There is no variable, so I got that as well. But I need different signs. This 2 is attached to a negative sign, meaning to make this number the inverse, or to eliminate it, I need to have a different sign. So I'm going to write a plus sign there. Plus sign, plus 2. Your teachers have already told you, I'm sure, that if you do something on one side of the equal sign, you need to do the same thing on the other. So if I have plus 2 over here on the left side, I need to do plus 2 on the right side. And then I just solve it. So my x that was not used up here, that just drops down. We didn't touch it. Negative 2. Sorry, formatting. Negative 2 plus 2 is 0. So that doesn't even need to drop down. That's just straight eliminated, right? We don't need to put it anymore. And then 6 plus 2 is 8. And we're left with an equation that reads x is equal to 8. All right, what does that mean? Well, it means that if we replace this x up here with 8, or if we substitute this x with 8, this equation will be true. So I always say check your answer before you do anything. So the way you check your answer is by using this 8 and then substituting it in for x. We don't need to put x anymore. So I always open parentheses when I substitute a number in for a letter or a variable. This 8 replaces x. Minus 2 equals 6. We just write it as it was up here. And we see if this is true. I use my calculator and I find out that 8 minus 2 does equal 6. This is correct. Now for the fun part. You need to tell me if there's one solution, if there's no solution, if there was infinite solutions. So let's start with no solution. No solution means there's no answer. There's nothing we could put in to replace x that would make this equation true. I see that we were able to plug 8 in to make this equation true. So I don't think there's no solution because I can clearly see that the solution is 8. So no solution is not going to be my answer. Infinite solutions means there are never ending numbers. You can use any number to make this true. But I think to myself, if I replaced that 8 and wrote 7, think about it. Would it still be 7 minus 2 equals 6? No. So I can't use another number except for 8 to make this true. The only number that you could take 2 away from to make 6 is 8. So when I answer this question, if 8's the only solution, I'm going to bold that, underline it, however you would like to show me if you're in my class. Other teachers, we use their own methods. But you don't only want to highlight or underline or bold this one solution and just leave it there. You want to explain. What do you mean explain? Well, I mean in words, explain how it's only one solution. I know that seems like I'm dragging it, but in order to, this is in replace of your state test. So in order to prove to the state that you truly understand this math, they want you to explain in words. So the way that or the words that I would use to explain how this is only one solution, I would say the only solution for x is 8. Some along those lines. Or you could write your own words. If I was a student, I would think into my head and I'd say 8 is the only number that would make this equation true. Just something simple. But you want to write in words, and you could use my example later, like the type of sentences that I'm using here. You could use that same structure. You just want to use different wording, maybe the different values, the different answers, of course. But you just want to demonstrate that you know it's only one solution, and you need to demonstrate it both with math and words. It's not something that I think you can't do. So that's the first problem out of these three. Let's look to this second one. It reads 3x, or 3 times x minus 2. Whenever the variable is next to a number, you know it's multiplication, right? Equals 3 times x plus 9. The first thing that I see, and if I asked you what you notice, you'd probably say you notice that there's a 3x on both sides. This is something that we haven't gone over yet in this video, but let's go over it now, and I'll explain to you what you need to do when you see the same variable, x, on both sides of the equal sign. So you already have been told that you can only have a letter on one side or a variable on one side of the equal sign when figuring out the solution. But right here, you see that there's a variable on both sides of the equal sign, and that variable is the same. It's x, and it just so happens that both of these x's have a 3 attached to it. So when I see a variable on both sides of the equation, I realize that the first thing I need to do is get that variable to one side. And I'm going to use the same process as before, using the inverse operations, as well as the rules for elimination. So usually I would look for the smaller number next to the x, or next to the variable. But in this case, we have 3's on both sides. So let's see what happens when I want to eliminate 3x from one side. I need the same number, I need the same variable, but I need a different sign. And this 3x is positive, so on the bottom I'm going to use the negative. And I already explained the rules. What I do on one side of the equal sign, I need to do the exact same thing on the other. When solving this, I go from top to bottom. So 3x minus 3x is 0, so I don't need to write anything below. My negative 2, always do this, by the way. My negative 2 is not touched. If we don't touch it, if we don't do anything to it, drop it down. Don't forget that negative sign, though. That also gets dropped down. Equal sign, drop that down. All right, 3x minus 3x. It's 0. We don't have to put anything. And since this plus 9 has not been touched, we could put 9. It remains positive. We just don't have to show the plus sign. And we're left with this equation that reads negative 2 equals 9. So, I'm going to ask you this question. Does negative 2 equal 9? Meaning, if you had negative $2 in your bank account and I have $9, do we have the same amount of money? We don't. So when you get something like this where nothing, like, it just doesn't make sense, like, you're going to say, no, that doesn't make sense, Mr. C. When you see something like that, that's a clear indication that it's no solution. So I'll explain. If negative 2 does not equal 9, then this can't have a solution, meaning there's no number that I can replace x with to make this true. And even if you read this straight up, 3x minus 2 equals 3x plus 9, on both sides, 3 is multiplying the same number. But after that multiplication, so after 3 multiplies to x on both sides, two different things happen. On the left side, it minuses 2, and on the right side, it adds 9. So I read this first, and I said, there's no way this possibly could be a solution, because no matter what number I plug in for x, that number is always going to have two different things happening. One side's minus 2, the other side's plus 9. So no matter what number plugged in here for the x, there will be a different result at the end of the day. So when you write your answer for no solution, you just simply write, there is no number that could replace x to make this equation equal. Or you know what? I messed up there. These expressions. Because remember, an equation is this whole thing separated by an equal sign. On each side of the equal sign, 3x minus 2, 3x plus 9, we call those expressions. So two or more expressions can be found in this equation. So that's your answer for no solution. Almost done with this problem, guys. I know it's a long video, but it's a lot to run through. The other ones will be shorter because we will already have our background information. All right, so take a breather, give yourself a couple seconds, and get ready for this last problem for practicing question 3. So we have 3x minus 7 equals 3x minus 7. And I would ask in class, here's a do now. It's like, give me one thing you notice about this. And the first thing people notice is that on each side of the equal sign, they see the same expression. 3x minus 7 and 3x minus 7. If I asked you, are these two expressions equal to each other? Are they the same thing? The majority of you would probably say yes, 3x minus 7 is the same thing as 3x minus 7, right? But we like you to show the work, so let's show the work. We look at this problem and we see something similar to the second set, whereas in 3x is on both sides. So we're going to do the same steps to eliminate the x's. We want to get x on one side, but in order to do that, we got to use the inverse operation or using the rules for elimination by having the same number, same variable, and different signs. Same number, same variable, different signs. And we do that on both sides of the equal sign. Don't forget, if you don't do it on both sides, we're going to get answers we don't want. Let's go down, up from top to bottom. 3x minus 3x equals nothing. Negative 7, untouched, gets dropped down. Equals 3x minus 3x is nothing. And the negative 7 gets dropped down. Don't forget to drop the negative signs. Negative 7 equals negative 7. So unlike our previous example, when we eliminated the number with the variable on both sides, it came out to equal negative 7 equals negative 7. And if I asked you, does the negative 7 equal negative 7? You'll say, Mr. C, yes, it does. If we both have that much money in our bank account, we have the same amount of money. So when you see this happen, where it's a number is equal to a number, you're dealing with infinite solutions. Now, how do I write that? Well, if for this one I wrote there is no number that could replace x to make these expressions equal, for this one you could write any number can replace x to make these expressions equal. You could even write something as like this. They are the same expression, right? And you see how computer formatting works. If you're writing and the table extends to this page, that is okay. So let's just go over what we did. For the first problem, we had x minus 2 equals 6. And I told you that you need to get x alone. To get x alone, we use the inverse operations to remove everything on the same side of x to this side. So if x is on the left, I need the left side to only have x, which means this -2 needs to be eliminated. To eliminate something, you need the same number. So here's -2. Same number is 2. I need the same variable. This 2 does not have one, so we're good. And then I need different signs. So this is negative, which means I put positive here. And I just put it underneath it, and it's going to eliminate. It's going to equal 0. Now, I cannot just do this on the left side. I need to do it on the right side, which means I also add 2 to the right side. 6 plus 2 can combine to make 8. And my x drops down on the left side, so I have x equals 8. I checked it, and I realized that the only solution for x is 8, and 8 is the only number that would make this equation true. We look to the second one. 3x minus 2 equals 3x plus 9. When you have variables on both sides, you should use the smaller value and eliminate it. What that'll do is that'll ensure that you only have a variable on one side. And when you eliminate the smaller one, you could still have the other one on the other side remain. But in this case, we have the same number next to the variable. So there's no smaller number, so we just eliminate 3x here and then 3x here on both sides, and we're left with -2 equals 9. We know that -2 does not equal 9, so that's no solution. And there's no number that could replace x to make these expressions equal. I challenge you. Try it. See if you can find a number that would make this equal. I don't think that you can. And this one. This one's the simplest in my opinion because it is the same expression, 3x minus 7, on both sides at equal sign. So we follow the same steps over here. We need to isolate x and get it to one side, so we eliminate the smaller value. Again, in this case, 3x is the same on both sides. So we still go through the same steps, and we figure out that -7 is equal to -7. When they are actually equal to each other after these steps, or you see the same expression on both sides, you should know that there are infinite solutions, and that any number can replace x to make these expressions equal. I hope this helped. I hope it wasn't too much, and I hope the next videos help even further when dealing with system of equations. I just want to tell you that these sentences that I wrote, they should also be included in your answers. So I don't, I'm not telling you to use my sentences, but when you apply these steps to the other questions or these questions in the portfolio that you'll have to answer, you see they're very similar, but they're different. I also need you to use sentences to explain your answer. So I need to see the math work. I also need to see these sentences. I also need to see you clearly state which solution set it is. So I look forward to you watching the other videos, and I hope everybody is able to knock this question out of the ballpark. It is a question that takes a little bit of time to do because there's 3 different steps, and your teachers will be there to guide you through them as well. So if you have any questions, feel free to ask your teachers, and I hope this helped.